All right, let's go ahead and do step number 2. So for step number 2, I'm going to start with f of x. F of x is equal to 4x plus 2. Step number 2 is I'm going to write g of x, or g of 4x plus 2, because I'm substituting it directly into my function. So this is going to be 1/4 times 4x plus 2 minus 1/2. I'm going to distribute that 1/4 to each term. That's going to make this 1/4 times 4, which is simply 1x. 1/4 times 2 is 2 over 4. 2 over 4 is really 1/2. And then I'm going to write minus 1/2 in order to continue with this problem. So plus 1/2 minus 1/2, these two are going to cancel, leaving me with just x. So because both ended up being x, I have verified that these two functions, f of x and g of x, are indeed inverses of each other. They are inverse functions. I would like you guys to go ahead and try example number 2 on your own. Can you verify that both f of x and f inverse of x are indeed inverses of each other's using compositions? So what you're going to do is over here, step 1, you're going to show that f of f inverse of x is equal to x. And over here, your step 2 is you're going to show that f inverse of f of x is also equal to x. If it is too confusing working with f inverse of x, you can change it to g and then reverse it back if you would like. If it's just too confusing. I understand that working with those exponents, we've only been working with it for maybe a day or so, can be kind of weird. So if you need to change it to g, that's fine. But I want you to go ahead and try that on your own. Let's go ahead and move on to number 3. So for example number 3, we want to use compositions to decide. So we're making a decision to decide if the following functions are indeed inverses of each other. So let's go ahead and look at letter A. The first thing I'm going to do is f of g of x. And I want to show that that is going to be equal to x. So what that's going to look like is, number 1, I have g of x. G of x is equal to 1/3 x minus 2. So I'm going to substitute this whole piece into my f function. So f of 1/3 x minus 2 is going to be equal to 3 times 1/3 x minus 2 plus 2. So this is going to be equal to 3 times 1/3. 3 over 3 is just simply 1x. 3 times negative 2 is negative 6, and then plus 2. Oh my. Looky here, we have x minus 4 is what we're left with. This is not x. So because this is not x, it's x minus 4. They're not the same. Put in any value. Put in a 10. 10 minus 4 is not equal to 10. It might work for other numbers, but these two are not, they're not balanced. They don't equal each other. So therefore, I don't have to continue. I can simply say that f of x and g of x are not inverse functions. They are not inverses of each other. Not at all, because I need them both to equal x. So I'm going to stop. Let's go ahead and look at letter B. For letter B, we have f of x and g of x. So I'm going to try my first one of f of g of x. And I'm going to start with g of x. So g of x is equal to, this one is 9/2 x minus 18. And I'm going to substitute this into my f function. So f of 9/2 x minus 18 is equal to 2/9 times 9/2 x minus 18 plus 4. So I have 2 times 9, which is 18. 9 times 2, which is 18. 18 over 18 is 1x. 2 times 18, or negative 18, is negative 36. Negative 36 divided by 9 is 4. So minus 4, and then plus 4. Negative 4 plus 4 cancels away. And so therefore, I am left with x. Cool. I have just showed that f of g of x is equal to f, but now, or equal to x. But now I have to show the other one. So I need to show that g of f of x is equal to x. That's what I need to show. So the first thing I'm going to start with is f of x. F of x is equal to 2/9 x plus 4. And I'm going to substitute this directly into my g functions. So that's going to be 9/2 times 2/9 x plus 4 minus 18. So this becomes 18 over 18 once again. So that is x. 9 times 4 is 36. 36 divided by 2 is 18. So plus 18 minus 18. The 18s go away and we're left with x. We have just shown that both f of g of x and g of f of x both ended up equaling x. And because they both ended up equaling x, they are inverses of each other. So yes, f of x and g of x are inverse functions. They are inverse functions. All right, let's go ahead and move on to the next page. So now, what I'm showing you here is a preview of where we're heading in later units. So we have talked a lot about quadratic functions and polynomial functions all the way up until this point. And so now where we're heading is we're heading into discussing and discovering information about their inverse functions. So A, B, and C are all quadratic, or this one's a cubic, a higher polynomial function. And so what we want to do now is we want to find the inverse of the function. And then we want to decide if that inverse is merely a relation or is it going to be a function. If it's just a relation, then we're going to write y equals in our answer. We're not going to use function notation because it's not a function. It's just a relation. But if it is a function, then we're going to make sure that we use that inverse notation. All right. The same steps are going to apply that we learned in a previous lesson, and that is that whenever you are trying to find the inverse function, we always replace f of x with y. So we're going to write this as y equals 1/3 x squared plus 7, and then we switch our variables. X equals 1/3 y squared plus 7. And the reason why we use y and x is simply because of its ease. Working with f of x and then x and switching those can get really confusing very fast. So that's why working with x and y makes things a little bit easier. I'm going to subtract 7 on both sides, and I end up with x minus 7 is equal to 1/3 y squared. Now, I am going to multiply both sides by 3. And what that's going to do is that's going to get rid of our fraction. The multiplication of 3 eliminates the division of 3, leaving us with 3x minus 21 is equal to y squared. Now, how do you get rid of a square? Well, we've learned using square roots. So I'm going to take the square root of both sides. And when I take the square root of both sides, I am left with plus or minus the square root of 3x minus 21 is equal to y. So therefore, I need to decide, is this good enough or should I do something different? So now let's think about that. The original function was 1/3 x squared plus 7. So my y-intercept would be at 7. That would also be my vertex, and my parabola would look something like this. There is no restriction on my parabola, so therefore I know that this graph will not pass the HLT, the horizontal line test. And so because I know it will not pass the horizontal line test, I know that this is just going to be a relation. And when I reflect this parabola across the line y is equal to x, I know it's going to be another parabola pointing on its side, and it will not pass the vertical line test and be a function. So therefore, it's just a relation. And we're going to leave our answer just like you see here. Let's go ahead and look at letter B. For letter B, I have g of x is equal to 4x cubed minus 5. So what I'm going to do is I'm going to rewrite this as y equals 4x to the third minus 5. And I'm going to rewrite this as x equals 4 times y to the third power minus 5. So I'm flip-flopping the x and y values. I'm going to add 5 to both sides. So I have x plus 5 is equal to 4 times y to the third power. I'm going to divide both sides by 4. And I end up with x plus 5 over 4 is equal to y to the third power. I'm going to leave my answer like this. If I wanted to change it into a different structure, I can and make it like 1/4 plus 5/4. There's nothing wrong with that. But my goal is to get y alone. So there's a couple of things that we're going to be heading into. One is going to be fractional exponents. The other one is going to be where we're going to be working with cube roots. So one thing I want to show you or give you a preview of is how to undo exponents using other exponents. Now, one thing I know about 3 is that 1/3 is its reciprocal. And I also know that 3 times 1/3 would equal 1. And I also know my properties of exponents, that whenever you raise a power to a power, you multiply those exponents. So since 3 times 1/3 is equal to 1, and I want y to be alone, I'm going to raise both entire sides to the 1/3 power. We're going to leave our power just like you see it. X plus 5 over 4, all raised to the 1/3 power, is going to equal y. I have y alone, so now the question is, should I leave the y or should I use inverse notation? So that goes back to the original function. This function, if you were to graph it in your graphing calculator, is going to look something like this. And it's going to pass. There's going to be no bumps to it at all. It will pass the horizontal line test. So you can use your graphing calculator or Desmos in order to analyze functions and to decide how your answer is supposed to be. But because it is not going to be a relation, your answer will be a function, we're going to write our answer as x plus 5 over 4 raised to the 1/3 power equals g inverse of x. And that is our answer. This is going to be a function. And finally, we have letter C. Oh, before I do that, let me talk about letter B. This to the 1/3 power is also known as a cube root function, and that is where we are heading. Cube root functions. They are going to be functions where it's going to look like a stretched out S. That's going to be a cube root function, and that's going to be in a future unit. All right, the next one that we have is letter C, and this time we're going to have a restriction on our domain. So we can pretty much tell that this is probably going to work because of our restriction on the domain, but let's go ahead and find that inverse first. So I have y is equal to x squared minus 3, and now I'm going to flip-flop my variables. X equals y squared minus 3. I'm going to add 3 to both sides so that I have x plus 3 is equal to y squared. And now you can take the square root of both sides. You can raise it to the 1/2 power, just like I showed you in the last example. But I think a lot of us are comfortable with square roots, so I'm going to rewrite this as square root. So now, in our last example, I had plus or minus. Whenever you take the square root of something, you put plus or minus in it. But because we have a restriction on the domain of x being greater than or equal to 0, These values of x being greater than 0 are all positive numbers. So therefore, out of our plus or minus, we use the plus out of the plus or minus. So therefore, our answer is going to be x plus 3 is equal to y. And now we decide if it's going to be this is a function. So x squared minus 3 is going to look like this. These are all of our values of our parabola where x is greater than or equal to 0. And this is our parabola. And this will pass the horizontal line test. So therefore, this is going to be a function. So therefore, we're going to rewrite this as square root of x plus 3 is equal to f inverse of x. And that is our answer. This is called a square root function. And the graph of this particular square root function is going to look like something like this. It's just going to be like a parabola, only on its side and only half of it. And as you guys can see based on my quick sketch, this graph does pass the vertical line test, and it's more specifically called a square root function. And like I said, we are going to be exploring these functions in a future unit. That is the end of today's lesson. If you have any questions over anything I showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.